Hi there, and welcome to another Popetti Math YouTube video tutorial where I'm going to be teaching you, yes you, Algebra 1. And in this video, we're going to look at our second example of average rate of change found in Lesson 5 of Chapter 2. In this exercise, it gives us the function g of x is equal to 2 minus 4 times x plus 3. And we want to start off by finding the average rate of change over the domain interval, -3 to 5. So again, we know a couple of things. We know -3 is one of our x values, and we know that 5 is our next x value because we want to start at this end of the domain interval and end with that side of the domain interval of +5. So there we have those. Now, how do we get our y values? Again, what we want to do to get those y values is substitute the value we do know in for x into our function. So in this case, we're going to have g of -3, and wherever we see an x, we're going to replace it with a -3. So it's going to be 2 minus 4 times -3 plus 3. And when I simplify that, please be careful to use order of operations. Our order of operations says to do parentheses first. So I'm going to combine inside these parentheses and get 0. And then I'm going to multiply that 0 by the 4, and I'm going to get 0. So it's 2 minus 0, which would give me 2. Remember, do not subtract these first. If you subtract these first, then you are doing addition and subtraction before your multiplication and division step in the order of operations, which is not correct. Now that we know that g of -3 is 2, we could put that in for our missing y value up here. And let's find out our missing y value when we substitute in 5. So we'll have g of 5. And again, we're just going to substitute in for an x. Wherever we see an x, we'll put a 5. So 2 minus 4 times 5 plus 3. 5 plus 3 will give me 8. 8 times 4 will give me 32. And 2 minus 32 will give me -30. So in here, I'll put in a -30. Okay, so that will also tell me that this missing y value is -30, and now I'm ready to use my average rate of change formula from up above over here. And again, you could use any of these three that you wish. You could use f of b minus f of a over b minus a. You could use y sub 2 minus y sub 1 over x sub 2 minus x sub 1, or you could just use the fact that it's the change in y over the change in x. All three will get you to the same solution. So I'm going to just take my change in y values, which is going to be found by subtracting -3 minus 2, and divide that by 5 minus -3. 5 minus -3. Be careful with that double negative right there. So that's going to give me -32 in my numerator. And in the denominator, I'm going to get 5 plus 3. That's going to give me 8, which will give me an average rate of change. I'll abbreviate it as average rate of change is -4. Okay. Find the average rate of change over the domain interval. Okay, so now we have decimals that we want to find. So that's not going to stop us. That's fine. That's perfectly okay with us. We could work with decimals. And if we can't, then we have this thing to help us out called a calculator. And we'll use that to help us out. Okay, so again, we're going to start at the domain interval of 2.5. That's going to be our one left restriction, and then our right restriction is going to stop us at 2.75. So a very small domain interval, but we're going to see where this takes us. So we're going to substitute in again 2.5 wherever we see an x. So we're going to do g of 2.5 is equal to 2 minus 4 times 2.5 plus 3. And when we simplify that, we'll get, well, 2.5 plus 3 is 5.5. 5.5 times 4 is 22, and 2 minus 22 is going to give us a -20. So there's our first missing y value. So I'll put a -20 in here. And now 2.75, we have g of 2.75 is equal to 2 minus 4 times 2.75 plus 3. And we're going to combine our inside of our parentheses, and we're going to get 2.75 plus 3 is 5.75. Times 4 will give us 23, and 2 minus 23 is negative. Oh, sorry, I thought I made an error there, but I did not make an error, so I apologize for that. And the reason why is because I got negative 21 here, and I was looking at my change in values here, and I was wondering why, if this looks awfully a lot like this equation here, then why is it only a change of 1 right here? But then I realized that my x values are going up. So it's okay to think that you're not on the right track, but when you go back and check your work, which is what I just did, which is why the video seemed like it paused for a second, or I paused for a second, it's okay to go back and check your work to attend to precision. And that's what I just did. So I attended to precision, and I made sure that I was doing the right thing before I went any further, because otherwise I'd be going further and possibly leading myself into a deeper and deeper hole. So now I'm going to take my two xy coordinates, and I'm going to find my change in y values. So that's going to be negative 21 minus negative 20. And then I'm going to put that over my change in x values, which is 2.75 minus 2.5. That's going to give me a, well, this is a plus, so this is going to be a negative 1 over, and this is going to give me a 0.25. And negative 1 divided by 1/4 is going to give me a negative 4, which now I could see that I'm on the right track, because that is the answer that I did get for part A. All right, so if this exercise video was helpful in allowing you to see the average rate of change between 2 points in this interval and 2 points in this interval given here were the same, and how you got the average rate of change given those intervals, give this video a thumbs up to let me know that I helped you out. You're now ready for the super short exercise number 3 found in the next video. You can access that by clicking on the link provided in here. Thanks for watching.